Going to be pretty short because most of it should be a review of some things that you know from your past. Today we're going to talk about changes of state, or the state of matter, or it's also called a phase change. So as we look at our phase changes, we're going to look at basically a change in the kinetic energy of the molecules. The molecules are going to move faster, or the molecules are going to slow down. So just a little bit of background knowledge. Remember, the coldest possible temperature is 0 Kelvin. At 0 Kelvin, there is no energy in any object at all whatsoever. You add energy, those particles start moving a little bit faster. Add more energy, they start moving faster, 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 faster. Which means that the closer that you get to 0 Kelvin, you are at a solid state of matter. You add more energy, those intermolecular forces get all kind of loosey-goosey, and they end up as a liquid. They can move past one another, but they still have intermolecular forces. Then eventually you add so much energy, they're moving so fast that those particles break their intermolecular forces and they're zooming around in space all by themselves. So the gas state has 0 intermolecular forces. They stick together, but they can move past one another. That is a liquid. And a solid state of matter means that the particles are in fixed positions, and when they're in those fixed positions, that just means that they are vibrating in place, but they can't move past one another. So you can go from one state of matter to another based off of how much kinetic energy they have. How we change the amount of kinetic energy something has is by changing the temperature. We add heat or we take heat away. Now, one thing to remember from like 8th grade science is that you can only transfer energy from a warmer object to a cooler object. It doesn't go from cold to hot. It goes from hot to cold. And we're going to talk a lot about that in our thermochemistry unit coming up in a few units. So as we add that energy or we take that energy away, we're going to strengthen intermolecular forces, we're going to weaken intermolecular forces, or we're going to completely break them all together. Gases have 0 intermolecular forces, liquids have weak intermolecular forces, solids are stronger. And that's pretty much what this slide right here says. So there's six phase changes. For your 6 phase changes, you have melting and freezing, which you started looking at when you were little bitty. Condensation and evaporation, they add in like 2nd or 3rd grade, so you should know what those are already. And then sublimation and deposition, typically people don't know what they are, especially deposition. So we will talk more about those than the other ones, but I'll still refresh your memory of what those mean. Now we do have some state of matter changes that require you to release energy. You're releasing heat. Remember, heat can only go from hot to cold. So that will help you to kind of think through this. But the ones that are releasing energy, you have something that's freezing. So if you have something that's freezing, you have a liquid, which is a higher amount of kinetic energy. That energy leaves the liquid and it turns into a solid. Or you have condensation, where you have a gas, that energy leaves the gas, the particles slow down and they turn into a liquid. Or you have deposition, which again we'll find out what that is in a second. Now, if we are absorbing energy, the opposite of that, I don't know why that is not a slide. That does not make any sense. Oh, there it is. I was going to say that doesn't make any sense to me. It was there. If you are absorbing energy, you are gaining kinetic energy. So the particles are moving faster and faster and faster. So if you are melting, you have a solid piece of matter, and those particles start moving faster, you weaken intermolecular forces, they turn into a liquid. Evaporation, the same thing. You have like a puddle on the ground. The sun hits it, the particles start moving faster, they break their intermolecular forces, they turn into a gas. So as we're going through these different phase changes, you have the temperature is going to increase. That is also going to increase the amount of energy that they have, or the opposite of that is going to happen. And right here on these flat lines is where you have a state of matter change happening. This means that it's in equilibrium with one another, so all those little intermolecular forces are all rearranging themselves and they are turning from one state of matter to another. So when we're doing temperature graphs, you're going to like increase the temperature, and as you increase the temperature, you're going to have a flat line there. When you have that flat line going between a solid and a liquid, that's because that's where all the change is happening. So it's called an equilibrium. So that's why they kind of look funny like this. But that is where the state of matter change happens. This is where state of matter change happens. We already did that one. All right. So we just had a huge ice storm here in Texas. And with that huge ice storm, you saw a lot of freezing and melting. Hopefully. Well, not hopefully, but you probably saw it. So let's say that it rains, and as it rains, the air temperature is cool, it freezes on your car. So this is a picture that was taken here, where a water main broke, and when that water main broke, it got all over the car. You can actually see this is the antenna of the car right here, the SUV. So that water went through freezing. Anything that was a liquid and it is now a solid is now frozen. So in the lab that we're going to do next week, you're going to take lauric acid and you're going to freeze it and melt it. If you have something that is plastic, like these little molecules, you can make it freeze and melt depending on its temperature. So I could take these, I could heat them up, the plastic will melt into a liquid, but then I can turn it into a new shape by putting it into a mold and it will freeze. So these are frozen, which is kind of weird for us to think about because usually we think about, oh my gosh, I'm freezing and it's really cold. However, these are frozen at room temperature. So anything that was a liquid and is now a solid is frozen. Now, if we go between the gas and the liquid state, this is evaporation and condensation. We'll talk a little bit about boiling later on. Boiling is a process of vaporization that happens from the bottom of the sample. Vaporization happens from the surface of the sample. Evaporation is kind of an all-encompassing term here. I said that backwards. Vaporization is all-encompassing. Evaporation happens from the surface. Wow. Okay, sorry. So you have your puddle here. And let's say that we have the sun shining down on it. And as the sun shines down on that puddle, those little particles start moving faster and faster and faster. They break free, they turn into a gas. So going from a liquid to a gas is evaporation, or vaporization is the all-encompassing term. Now those little water vapors are out in the air. At the dew point, early in the morning, it gets real cold. Those particles slow down and they go through condensation where they accumulate on a leaf or on your windshield. This also happens if you have like a glass of water and there's ice on the inside. The air temperature is warmer. When it hits that colder glass, it causes condensation, and so it feels wet on the outside. Your glass isn't leaking. It is from the air itself. Now the new ones. You have sublimation and deposition, which you probably have never heard of before. We saw deposition in Texas for the first time in I don't know how long. And then sublimation you've probably seen before, you just didn't know that you saw it. So anytime you go from a solid to the gas state of matter, that's called sublimation. This picture right here in the bowl, that is dry ice. When you have dry ice, it goes directly from the solid state, that dry ice, into carbon dioxide gas. There is no liquid in between there. You have a solid, it's going directly to a gas, that is sublimation. The deposition is what happens to make snowflakes or to make like frost on your car in the morning. You have water vapor in the air, and then it's going to turn into a solid very quickly. So because it turns into a solid so quickly, it makes these fun little ice crystals. So sublimation happens. I've got a one of these little renews it, I'm probably saying that wrong, room fresheners. They make a smell. These were really big in the 80s and early 90s. People would put them like all over their house because plugins used to make houses catch on fire. But you'd put this on like the back of your bathroom, like on your toilet or whatever. But it is a kind of like a gel-like substance that's on the inside of here, and it used to be filled up all the way to the top up here. But what is actually happening is it's creating a scent, which is Hawaiian sunset, which means that if I go to Hawaii, wherever it is, there it is. If I go to Hawaii, apparently this is what it smelled like at sunset. I doubt it, but okay. So we have our solid substance here. It's turning directly to a gas because I can smell it. Smells are all gases when they're in the air. So this is going directly from the solid state to the gas state. So this is sublimation. That also happens in mothballs. Mothballs are stinky. People put them around their house or around like campers and things like that. They say it keeps away snakes. It actually doesn't. But that's the urban legend that it is. But with your mothballs, they are solid little white round things, and they emit a horrible odor. It's called naphthalene. And that horrible odor means that it's going directly from the solid state to the gas state. Dry ice we already talked about, and then also this happens in your freezer. Every time you open up your freezer door, you have a lot of energy that goes into your freezer very quickly. Because remember, it can only go from hot to cold. So you're not letting the cold air out, you're letting the warm air in. So with your freezer, you add that energy, and that's causing like your ice cubes to go through sublimation. So if you ever find one of those little runaway ice cubes that are in the bottom of your freezer or something when you're cleaning it out, or it's in the back of the shelf or whatever, they're always smaller. The reason why they're smaller is that energy hits those ice cubes and it turns into like a steam or a water vapor that goes into your air. Sometimes you can see it, like we have a freezer in our garage, and if you open up the freezer in the garage in like the summertime, you have this like cloud that comes out. That's because of sublimation. Now deposition, again, we got to see this last week in Texas, where you make snowflakes. You have water vapor that's in the air, it hits a cold front, and very rapidly that water vapor, the gas, turns into solid. And that's what creates all the cool little crystals here for your different snowflakes. This also happens, like I said, with frost on your car. You have the water vapor in the air, it hits your cold car, and it causes everything to freeze onto your windshield without actually going from the solid to the liquid to the gas to the liquid to the solid state. It skips that liquid state altogether. So we are going to look at just a couple more words real quick, and then we're going to be done for the day. Vaporization, I already talked about. It's anytime a liquid changes from a gas to a gas or a vapor. We're going to talk about the difference between gas and a vapor later on. But it is that like evaporation type thing, but it also encompasses boiling. Evaporation can only occur on the surface. Boiling can happen from the bottom of the liquid down. Up. I even said up. Sorry, it's been a long day. So there is a difference there, but we kind of use those two terms interchangeably. Technically, it would be vaporization, but you can also say evaporation. And then there is one more term that we need to define this year, and that's a volatile liquid. A volatile liquid is one that's going to have very weak intermolecular forces. So those are the forces that hold together the little molecules. And it will evaporate very, very, very easily. Think about rubbing alcohol, or think about gasoline or something like that, where you have the liquid that's there and it goes into the air very quickly and very easily, because those little particles are able to escape because of their weak intermolecular forces. So that's actually where we're going to stop for the day. I believe that is everything, but you do not have a an assignment over this. We're actually going to lump this in with the next little topic, and that next little topic is phase diagrams, and then there'll be one assignment altogether. I hope you have a great day.